Today is 1st of June 2025. Uh, I will talk about wireless link connection, SNR versus BER trade-off. Uh, BER is the necessity condition, the requirement that you should specify. It's different by the data, by whether it is voice call, whether it is video. It should be some line 10 to the minus 7 will be the advanced. If you must satisfy 10 to the minus 7, what SNR source noise ratio should be uh, if you are 10 if you are more than 10 if your SNR is if your SNR if your SNR is, let's say, 10, then what you can only use is BPSK. If you use QAM, then it will be over there, that it will make 10 to the minus 1 error, 10 to the uh decibel, then it will make 10 to the minus 1 error. It is very, very bad. And this QAM is changing the angle and amplitude. It does not use phase. Whether using phase is, it becomes 0, and uh, this sign becomes 1, then it will be using phase. So increased power will increase SNR and decrease BER. And this is a very important wireless link characteristic related with access point. Because when you are moving, if you go further from AP, then SNR will decrease, then BER will increase. That is what uh, trade-off. And there's so modulation noise is related to effective BER. So CDMA is about dot product each other. And there's about frame addressing and so on. Uh, and frame is changing, MAC address is changing, but IP address is not changing. I'm a bit confused why. And for the preparation of finer, first thing, important thing is floated vs unfloated Aloha. If you see the Aloha, well, we should think about why Aloha came out. Um, First, it is random access protocol of one of the MAC protocol. There was several MAC protocol, and one of the protocol is random access protocol, which starts random access, and there's like good property, which is you can use it when transmission rate is lower than 1. You can use it because it's assuming if there are a lot of people or offended ones, that there will be definitely a collision, then you can use it. We can also prove it mathematically later. So there is floated Aloha CSMA, floated Aloha assumption. Let's see with the slides. Assumption, all frames are size, all frames are same size, time divided into equal size slot. Nodes start to transmit only slot beginning. Nodes are synchronized. If two or more nodes transmit in slot, all nodes detect collision. So if you see the mathematics, how it works is, if collision happen, probability of collision will be P1/n. So let's say n we are going to find n. Uh, or, if collision happen, then let's say n people. Each of people has 1 over n probability of sending. The successful slot will be NC1, only one people send. So, and another people not sent, which is 1 minus p to the n minus 1. Then each people cases, we should multiply n. Then it will be max, there will be max fp. And we set p equals to 1 over n, so f1 over n will be 0.37%. I'm curious bit of even p and 1 over n is equivalent, but if we change f p to f1 over n, is there any changes? I'm a bit confusing about that one, 6.5. For floated alloys efficiency, it will be probably to any node has n multiply p multiplied by 1 minus p power to n minus 1. So max efficiency, find p that maximize np 1 minus pm minus 1 will be, if we calculate it, it will be 0.37. So pure aloha, um, it's more simpler. There's no assumption. Frame centered T0 collides with frame centered T0 minus I to T0 plus I. Uh, it has higher, it has higher, mm, it has higher collision rate, so it cannot go further of 0.37. And then there's CSMA come out. CSMA, CD is about collision detection. CSMA is about carrier sense multiple access, which is listen before transmission. But even listen before transmission, there can be collision happen. Mm, because it's wireless link, so they have distance, because they have propagation delay, so they can't even, they have possibility of not realizing it. CSMACD is about collision detection. It can detect collision. And yeah, we also talk about how to block collision in CSMA and CD. What we are using is binary exponential backup, which is if you fail, then there will be 2 to the multiply, you will have more choices. So it's kind of similar concept with um, of 1%, the probability will be low that one person will send. It is binary backup, exponential backup. And CS, systemicity efficiency. Collision is basically because of propagation, if we simply say. And there's taking turn MAC protocol, which is there's channel partitioning and so on. And there's cable access network come out. It's about uh, DOCSIS, which is data over cable, which is cable access network, cable service interface specification. Yeah, there's situation difference between FDM over upstream, PBM upstream, which is downstream frequency channel, and some slots assigned. Some have contention, downstream MAP frame, assigned upstream slots, request for upstream slots, transmitted random access in selected slots. So summary of MAC protocol is there's channel partitioning algorithm, and there is random access, and there's taking turn. Mm. And because it's review, I will go to chapter 5. I want to talk about also these network control planes, uh, BGP. BGP is concept that is and also distance vector algorithm very soon. There's a floated arrow algorithm and distance vector algorithm. And yeah, adaptive modulation. So we talk about MAC protocol and wireless link characteristic, CSMA. And for BGP, tree-flop ICMP. We'll talk about ICMP and BGP. If we go to BGP first, let's go to BGP. And we will also talk about distance vector. In data network layer, there is controller plane and data plane. Control plane to routing. What we are talking about is control planes routing. How determine route taken by packets from source to destination. So there's Dijkstra algorithm and there is Bellman-Ford algorithm, distance vector, Bellman-Ford algorithm. Let the xy cost of least cost path from x to y, then the xy will be minimum taken over all neighbors phi of x, which is c. which is cx comma y plus dvy. It's kind of complicated. I want to find the intuition if possible. I didn't find it yet. Sesame City. Distance vector algorithm. So this situation that with the image of the with the image, uh, when you calculate dUg, you can calculate it by minimum of cu comma v plus dvg, or cu comma x plus dxg, or cu comma w plus dwg. So your estimation is works like this. Key idea is from time to time, each node sends its own distance vector estimate to neighbors. They advertising, and when X receives new distance vector estimate from neighbors, then it will update it. If X updates received, then it will update using Bell-Manifold equation. It's updating its things by Bell-Manifold equation. And so iterative, asynchronous, and each node distributed. So we should wait, recompute, and notify it again. And when three nodes, then there will be three tables, and each nodes are by propagating their algorithm is changed. Yeah, link cost change is so very big deal. And there's Poisson to reverse situation. And there is infinity problem regarding this one. If G tells Y its distance to X is infinite, then will it completely fail to count the infinity problem? Okay. And there is BGP problem regarding ISP. So BGP is border gate control, and it's all about policy. Policy in real world situation, there can be uh, big companies which manage these things. So there is eBGP connectivity and iBGP. Gateway between is eBGP connectivity, BGP session to BGP router, exchange BGP message over semi-permanent TCP connection. Advertising path to different destination network prefix. BGP is a path vector protocol when AS3 gateway router 3A advertise path AS3X to AS2 gateway router 2C. AS3 promises to AS2 it will forward datagram toward X. Path attribute and BCP routes. Advertised prefix includes BCP attribute. Prefix plus attribute equals to route. And there's two important features, which is SPath and Next Hope. Uh, they do policy-based routing. So it's kind of graduate school student issue topic. How can we get more gain? I think it's kind of it will be related with game theory, whether they should advertise or not. Like advertising will give others make money, but they will cost their money, so they should think about it. As AS2 router with 2C receives pass advertisement, AS3X from AS3 router 3A based on AS2's policy, AS2 router 2C accepts pass AS3X propagates via IBCP to all AS2 routers, and based on AS2 policy, AS2 router 2A advertise pass AS2 AS3, X to AS1 router 1C. Then gateway router may learn about multiple paths to destination. AS1 gateway router 1C learn pass AS2 AS3 X from 2A as AS1 gate router 1C runs path from AS3, X from 3A. Based on policy, AS1 gateway router 1C chooses path AS3X and advertise path within AS1 via BCP. So BCP message, they have open, update, keep alive notification. BCP messages, open, update, keep alive notification. This is how they forwarding. They have forwarding entries. BCP. Then they will record that 1A, 1B, 1C from about destination X. Yeah, this is topic about how potato routing. BCP achieving policy via advertisement. Potato routing. Also, it can be different by inter and intra routing in policy, scale, and performance point of view. It will be different. And for ICMP, it's about Internet Control Protocol messages. ICMP are also related with traceroute because this topic, traceroute is the program just based on this. ICMP has type code definition, so you can check by Wireshark whether your things have problem or not. Okay. Lastly, I will do quick review on what we did today. So we have Aloha issue, which is random access protocol, one of the random access protocol and one of the MAC protocol. It has efficiency of 37% and it made probability as 1 over n. There's reason because expectation becomes 1%. You should think about unit when calculating 1%. And next, distance vector algorithm, it use dxy equals to minimum of v, cx, y, cx, y plus dvy and control plane routing is related with, and when good use case, bad use case, and count to infinity case. And there's adaptive dynamic modulation technique, which is what affect SNR because it's wireless situation. And what does it affect to BER? Moving distance from AP, where decrease SNR, then adapted SNR dynamically. A BER requirement is the minimum requirement that we should choose. So based on BER, we can choose SNR. If it's here, then we can use this one. And if it is 15, we probably use this blue BPSK. Or if it is way better than 20, we can maybe use QAM16 or QAM256. DOCSIS, data over cable interface spec, cable network link. So it was related with based on cable, and MAC protocol, TDMA, and it is time-based, and FDMA, and there's random access, and there is turn change. For wireless link characteristics, AP is moving, and Bellman-Ford equation, and CSMA is also about notify, but collision happened, what should we do? Trace route, ICMP is about type code plus first 8 byte of IP datagram causing error used by host and routers to communicate network level info. Error reporting exists. CSMA CD efficiency. Yeah, because basically because propagation delay, and so there is binary exponential backup and other things that we can do. Distance vector, random access algorithm, and BGP, providing policy, flooded aloha, and pure aloha CSMA. How can we solve it? In Ethernet situation, and MAC protocol. So this was today's summary. Thank